All right, this is the alcohol groups done by Matthew Kempner and Kristen Urinen. Kristen did the handout and did not want her voice going on the internet, so I will be doing the commentary for this. Any visuals will be on the handout. If you have any questions, just look at the handout. It has all the information that I'm reading. All right, so the characteristics. Structural. Alcohols differ in the number of carbon atoms in the molecules and with placement of the OH groups. The general formula is R connected to an OH. R is any alkyl group. Um, the functional group of alcohols is a hydroxyl group, which is or OH. Physical characteristics. Most of them are colorless liquids at room temperature. Ones containing 4 to 10 carbon atoms are somewhat viscous and have heavier fruity odors. Ones with more than 12 carbons are solids at room temperature. And OH makes alcohol molecules polar and gives them the capacity to form hydrogen bonds. As for chemical, primary alcohols can be oxidized to aldehydes and onto carboxylic acids. Secondary alcohols can be oxidized to ketones, and tertiary alcohols are resistant. So, for oxidation acids or oxidation reactions, primary alcohols can be oxidized to aldehydes and or carboxylic acids, as stated before, whereas secondary will terminate at the ketone stage, and tertiary alcohols are resistant to oxidation. So there's an image of what an oxidization reaction would look like on your handout. I can't really explain it any better than it is already shown there. So substitution. Primary alkyl halides react with aqueous sodium. What is that again? Sodium hydroxide and potassium hydroxide, I guess. Mainly to primary alcohols and nucleophonic aliphatic substitution. Secondary and especially tertiary alkyl halides will give the elimination product instead. Uh, yeah. Hydrolysis reactions is when alkenes engage in an acid catalyzed hydration reaction using concentrated sulfuric acid as a catalyst that gives usually secondary or tertiary alcohols. The hydroboration oxidation and oxymercuration reduction of alkenes are more reliable in organic synthesis. Alkenes react with NBS and water in halohydrin formation reaction. Amines can be converted to diazonium salts, which are then hydrolyzed. We have a picture of a secondary alcohol being formed via reduction, and hydration is shown. That'll be on your handout as well. For dehydration, we have or alcohols are themselves nucleophonic. So ROH2 plus can react with ROH to produce ethers and water in a dehydration reaction. Although this reaction is rarely used except in the manufacture of diethyl ether. More useful is the E1 elimination reaction of alcohols to produce alkenes. The reaction, in general, obeys I can't pronounce that guy's name, but I'll attempt to. It's Zaitsev's rule, which states that the most stable, usually the most substituted, alkene is formed. Tertiary alcohols eliminate easily at just above room temperature, but primary alcohols require a higher temperature. So there's a diagram of an acid catalyzed dehydration of ethanol to produce ethene. Yeah. So for where are we now? Esterification. To form an ester from an alcohol and a carboxylic acid, the reaction known as Fischer esterification is usually performed at reflux with a catalyst of concentrated sulfuric acid. There is an equation on your sheet showing what happens. I myself don't understand it that well, but I'm sure there's some smart people out there who do. Other types of ester are prepared in a similar manner. For example, tosylate esters are made by a reaction of the alcohol with p-toluene sulf. I can't pronounce chemical names, but there is or that name is written down on your handout. This is when a carbo. Anyway, there's a diagram where a carboxylic acid monomer and an alcohol. Oh shoot, we've moved on to the next thing. Anyway, so after that is condensation polymerization. This is when a carboxylic acid monomer and an alcohol monomer join in an ester linkage, releasing an H2O. So there is another equation showing how the alcohol and the acid are releasing the H2O and how that equation works out. Last is addition reactions, which is for inorganic chemistry. A nucleophilic addition reaction is an addition reaction wherein a chemical compound, a pi bond, is removed by the creation of two new, what's that symbol? I think that's theta bonds by the addition of a nucleophile. So again, there's an image of that on your handout, and it shows that you have a double bond to an oxygen. When one of these nucleophiles are added, then you are given or the shape is rebuilt, and you're adding another hydrogen and getting an OH group on the top. So yeah, that's what we learned about alcohols. I don't understand all of it, but I'm sure if you guys need anything more, Wikipedia should have the information, although I'm not supposed to say that. Just make sure that you're checking the citations. And yeah, I'm sure you're bored out of your mind now, so have fun.